So here's some notes on the change of base formula, and it's pretty easy. The change of base formula basically says that the log to the base b of m can be written as the log to the base a, some other base of m, over the log to that same base a of b. And you can just see this m goes on the top and this b goes on the bottom, so this is higher than that, so it's pretty easy to remember it. And this allows us to calculate some logs that we don't normally have on our calculators, and most calculators have just log or ln, and that's either natural log or common logs. So if we have something like log to the base 7, most of our calculators can't do that in that form. So what we would do is we could use the change of base formula, and we could use regular logs, and we could say that that's going to be the same thing as log to the base 10 of 14 over log, and if we don't see anything, that's considered the base 10 of 7. So just, and then you can calculate that out, and I've got my calculator here, so I'll use the log. And over here's the log right here, you can see log. So log, oops, let me turn it on. So we got log, and that's base 10, so we'll just say 14. Parentheses, and we can divide that by log 7, and enter, and you get 1.35, about, or 1.356 if we round off to 3 places. So we use the little approximation signs, that would be 1.356. Now if we use natural logs, it'd be the same, it would come out the same thing. Let's say we use ln of 14 divided by natural log of 7. Same thing. See, so it doesn't matter whether you use, oops, natural logs. Hope you can see that better. Okay. There you go. Okay. So let's try another one. So just that log over that log, and I didn't work them out step by step, but you could see it's pretty easy to calculate. So this one over here, that'd be the log of 24 over just the log of 9. And I can work this out in steps for you if that might make it a little bit better. Let's clear this. And we could have the log of 24, so I use log again, log of 24 equals, and we could say 1.38 1.3802, and what will be the log of 9, and that'd be 0.9542, and then we just divide those. Now this is the long way, you could just do it a little bit easier, but you can just say 1.3802 divided by 0.9542, and you get about approximately 1.4464. Now we have a little round-off error because we didn't put all these digits in when we did it the other way. In other words, if I just write the log of 24 divided by the log of 9, we get a little bit different decimals because I'm carrying out all these decimals. I rounded it off. I cut it off. I kind of rounded off or truncated at 4 places, but there's some other places that will make a difference. So a more accurate rendition would be 1.44639, and that would still average out to be the same thing, 1.4464 if we carry out to 4 places, but we've got a little more accuracy out in these places because we carried all those decimal places. And again, if you use natural log, you get the same thing, so you can see that. We can just show you one more time. The natural log of 24 divided by the natural log of 9. You get the same exact thing. And like I say, most calculators have log and natural log, but they don't have the option to do different bases. Now some of the newer ones do, so if you've got one of those, don't worry about it. But we do use the change of base formula in higher mathematics in a lot of different ways rather than just finding logarithms. We use them to derive different formulas, so they're very valuable in that case. So you want to know this formula. This is the change of base formula. Okay?